The Tao of Physics, an exploration of the parallels between modern physics and Eastern mysticism, by Fritjof Capra. This book beautifully interlaces modern-day physics with mysticism, illustrating in one way after another how the field of physics is making statements that sound enjoyably similar to what mystics have been sharing with us throughout history. Fritjof Capra educates us about Eastern philosophy and modern physics, and he does a great job of it. Then he couples them again and again to exhibit the remarkable similarities between the observations that they propose. Reading the Tao of Physics does require focus and attention to detail and interest in understanding concepts that could be called difficult to comprehend. Sure, what I notice is that Capra does an excellent job of guiding us through it, and there's quite a reward for doing so. I found myself gasping and giggling quite a few times through the book as it opened my awe and wonder and uncovered the doorway that is always available to us, but that we so often walk right by and don't notice in our peripheral, the doorway to mystery. Without further ado, I'll share my vocal readings from Book 37, Fritjof Capra's The Tao of Physics. Enjoy. Page 23. The natural environment is treated as if it consisted of separate parts to be exploited by different interest groups. The fragmented view is further extended to society, which is split into different nations, races, religious, and political groups. The belief that all these fragments in ourselves, in our environment, and in our society are really separate can be seen as the essential reason for the present series of social, ecological, and cultural crises. It has alienated us from nature and from our fellow human beings. It has brought a grossly unjust distribution of natural resources, creating economic and political disorder, an ever-rising wave of violence, both spontaneous and institutionalized, and an ugly, polluted environment in which life has often become physically and mentally unhealthy. Page 51. What we see or hear are never the investigated phenomena themselves, but always their consequences. The atomic and subatomic world itself lies beyond our sensory perception. It is then, with the help of modern instrumentation, that we are able to observe the properties of atoms and their constituents in an indirect way, and thus to experience the subatomic world to some extent. This experience, however, is not an ordinary one, comparable to that of our daily environment. The knowledge about matter at this level is no longer derived from direct sensory experience, and therefore our ordinary language, which takes its images from the world of the senses, is no longer adequate to describe the observed phenomena. As we penetrate deeper and deeper into nature, we have to abandon more and more of the images and concepts of ordinary language. On this journey to the world of the infinitely small, the most important step from a philosophical point of view was the first one, the step into the world of atoms. Probing inside the atom and investigating its structure, science transcended the limits of our sensory imagination. From this point on, it could no longer rely with absolute certainty on logic and common sense. Atomic physics provided the scientists with the first glimpses of the essential nature of things. Like the mystics, physicists were now dealing with a non-sensory experience of reality, and, like the mystics, they had to face the paradoxical aspects of this experience. From then on, therefore, the models and images of modern physics became akin to those of Eastern philosophy. Page 66. Every time the physicists asked nature a question in an atomic experiment, nature answered with a paradox. And the more they tried to clarify the situation, the sharper the paradoxes became. It took them a long time to accept the fact that these paradoxes belong to the intrinsic structure of atomic physics, and to realize that they arise whenever one attempts to describe atomic events in the traditional terms of physics. Page 68. At the subatomic level, the solid material objects of classical physics dissolve into wave-like patterns of probabilities, and these patterns ultimately do not represent probabilities of things, but rather probabilities of interconnections. A careful analysis of the process of observation in atomic physics has shown that the subatomic particles have no meaning as isolated entities, but can only be understood as interconnections between the preparation of an experiment and the subsequent measurement. Quantum theory thus reveals a basic oneness of the universe. It shows that we cannot decompose the world into independently existing smallest units. As we penetrate into matter, nature does not show us any isolated basic building blocks, but rather appears as a complicated web of relations between the various parts of the whole. These relations always include the observer in an essential way. Page 78. When two particles collide with high energies, they generally break into pieces, but these pieces are not smaller than the original particles. They are again particles of the same kind and are created out of the energy of motion involved in the collision process. The whole problem of dividing matter is thus resolved in an unexpected sense. The only way to divide subatomic particles further is to bang them together in collision processes involving high energies. In this way, we can divide matter again and again, but we never obtain smaller pieces because we just create particles out of the energy involved in the process. The subatomic particles are thus destructible and indestructible at the same time. This state of affairs is bound to remain paradoxical as long as we adopt the static view of composite objects consisting of basic building blocks. Only when the dynamic relativistic view is adopted does the paradox disappear. Page 107. This diagram is a symmetric arrangement of the dark yin and the bright yang, but the symmetry is not static. It is a rotational symmetry, suggesting, very forcefully, a continuous cyclic movement. The yang returns cyclically to its beginning. The yin attains its maximum and gives place to the yang. The two dots in the diagram symbolize the idea that each time one of the two forces reaches its extreme, it contains in itself already the seed of its opposite. Page 140. The crucial feature of atomic physics is that the human observer is not only necessary to observe the properties of an object, but is necessary even to define these properties. In atomic physics, we cannot talk about the properties of an object as such. They are only meaningful in the context of the object's interaction with the observer. In the words of Heisenberg, what we observe is not nature itself, but nature exposed to our method of questioning. The observer decides how he's going to set up the measurement, and this arrangement will determine to some extent the properties of the observed object. If the experimental arrangement is modified, the properties of the observed object will change in turn. Page 161. Modern physics has confirmed most dramatically one of the basic ideas of Eastern mysticism, that all the concepts we use to describe nature are limited, that they are not features of reality as we tend to believe, but creations of the mind, parts of the map, not of the territory. Whenever we expand the realm of our experience, the limitations of our rational mind become apparent, and we have to modify or even abandon some of our concepts. Page 170. Clocks in motion run slower. Time slows down. These clocks can be of varying types: mechanical clocks, atomic clocks, or even a human heartbeat. If one of two twins went on a fast round trip into outer space, he would be younger than his brother when he came back home, because all his clocks, his heartbeat, blood flow, brain waves, etc., would slow down during the journey. From the point of view of the man on the ground, the traveler himself, of course, would not notice anything unusual, but on his return he would suddenly realize that his twin brother was now much older. Page 171. All these relativistic effects only seem strange because we cannot experience the four-dimensional space-time world with our senses, but can only observe its three-dimensional images. These images have different aspects in different frames of reference. Moving objects look different from objects at rest, and moving clocks run at a different rate. These effects will seem paradoxical if we do not realize that they are only the projections of four-dimensional phenomena, just as shadows are projections of three-dimensional objects. If we could visualize the four-dimensional space-time reality, there would be nothing paradoxical at all. The Eastern mystics, as mentioned above, seem to be able to attain non-ordinary states of consciousness in which they transcend the three-dimensional world of everyday life to experience a higher, multi-dimensional reality. Page 194. The closer we look at it, the more alive it appears. All the material objects in our environment are made of atoms which link up with each other in various ways to form an enormous variety of molecular structures which are not rigid and motionless, but oscillate according to their temperature and in harmony with the thermal vibrations of their environment. In the vibrating atoms, the electrons are bound to the atomic nuclei by electric forces, which try to keep them as close as possible. And they respond to this confinement by whirling around extremely fast. In the nuclei, finally, the protons and neutrons are pressed into a minute volume by the strong nuclear forces and consequently race about with unimaginable velocities. Modern physics, then, pictures matter not at all as passive and inert, but as being in a continuous dancing and vibrating motion, whose rhythmic patterns are determined by the molecular, atomic, and nuclear structures. This is also the way in which the Eastern mystics see the material world. They all emphasize that the universe has to be grasped dynamically as it moves, vibrates, and dances, that nature is not in a static, but a dynamic equilibrium. Page 203. Atoms consist of particles, and these particles are not made of any material stuff. When we observe them, we never see any substance. What we observe are dynamic patterns continually changing into one another, a continuous dance of energy. Quantum theory has shown that particles are not isolated grains of matter, but are probability patterns, interconnections in an inseparable cosmic web. Relativity theory, so to speak, has made these patterns come alive by revealing their intrinsically dynamic character. It has shown that the activity of matter is the very essence of its being. The particles of the subatomic world are not only active in the sense of moving around very fast, they themselves are processes. The existence of matter and its activity cannot be separated. They are but different aspects of the same space-time reality. Page 223. The relation between the virtual particles and the vacuum is an essentially dynamic relation. The vacuum is truly a living void, pulsating in endless rhythms of creation and destruction. The discovery of the dynamic quality of the vacuum is seen by many physicists as one of the most important findings of modern physics. From its role as an empty container of the physical phenomena, the void has emerged as a dynamic quantity of utmost importance. The results of modern physics thus seem to confirm the words of the Chinese sage Chang Tsai. When one knows that the great void is full of qi, one realizes that there is no such thing as nothingness. Page 244. The dance of creation and destruction is the basis of the very existence of matter, since all material particles self-interact by emitting and reabsorbing virtual particles. Modern physics has thus revealed that every subatomic particle not only performs an energy dance, but also is an energy dance, a pulsating process of creation and destruction. Now I'm skipping over to page 245. For the modern physicists, then, Shiva's dance is the dance of subatomic matter. As in Hindu mythology, it is a continual dance of creation and destruction involving the whole cosmos, the basis of all existence and of all natural phenomena. Hundreds of years ago, Indian artists created visual images of dancing Shivas in a beautiful series of bronzes. In our time, physicists have used the most advanced technology to portray the patterns of the cosmic dance. The bubble chamber photographs of interacting particles, which bear testimony to the continual rhythm of creation and destruction in the universe, are visual images of the dance of Shiva, equaling those of the Indian artists in beauty and profound significance. The metaphor of the cosmic dance thus unifies ancient mythology, religious art, and modern physics. Page 286. In the New World view, the universe is seen as a dynamic web of interrelated events. None of the properties of any part of this web is fundamental. They all follow from the properties of the other parts, and the overall consistency of their mutual interrelations determines the structure of the entire web. Skipping down. The bootstrap hypothesis not only denies the existence of fundamental constituents of matter, but accepts no fundamental entities whatsoever, no fundamental laws, equations, or principles, and thus abandons another idea which has been an essential part of natural science for hundreds of years. The notion of fundamental laws of nature was derived from the belief in a divine lawgiver, which was deeply rooted in the Judeo-Christian tradition. In the words of Thomas Aquinas, there's a certain eternal law, to wit, reason, existing in the mind of God and governing the whole universe. This notion of an eternal divine law of nature greatly influenced Western philosophy and science. Descartes wrote about the laws which God has put into nature, and Newton believed that the highest aim of his scientific work was to give evidence of the laws impressed upon nature by God. To discover the ultimate fundamental laws of nature remained the aim of natural scientists for the 3 centuries following Newton. In modern physics, a very different attitude has now developed. Physicists have come to see that all their theories of natural phenomena, including the laws they describe, are creations of the human mind, properties of our conceptual map of reality rather than of reality itself. This conceptual scheme is necessarily limited and approximate, as are all the scientific theories and laws of nature it contains. All natural phenomena are ultimately interconnected, and in order to explain any one of them, we need to understand all the others, which is obviously impossible. I'm on page 336. This will be the final passage that I read from this book. The reason the Tao of Physics could be perceived as a threat lies in a widespread misunderstanding of the nature of mysticism. In the scientific community, mysticism has generally been thought of as something very vague, fuzzy, nebulous, and highly unscientific. To see one's cherished theories compared with this vague, fuzzy, and suspect activity is naturally quite threatening to many physicists. This erroneous view of mysticism is really very unfortunate, because when you look at the classic texts of mystical traditions, you will find that deep mystical experience is never described as vague or nebulous, but on the contrary, is always associated with clarity. Typical metaphors to describe the experience would be lifting the veil of ignorance, cutting through delusion, cleansing the mirror of the mind, perceiving the clear light, unexcelled complete awakening, all of which imply great clarity. Mystical experience does go beyond intellectual analysis, so the clarity is of a different kind, but there's certainly nothing vague or fuzzy about these experiences.